Dear participants, our next expert is already joined with us, Dr. Jyoti Mandal. Good afternoon, sir.
Okay, Dr. Mihal.
So, Hajra, please introduce Jyoti, sir.
Good afternoon, all. Now, in this session, we have an eminent expert, Dr. Subhrajyoti Mandal sir, Principal Gen AI Engineer. Dr. Subhrajyoti Mandal, Principal AI Engineer at Advanced AI Inside GSK, leads the design and implementation of AI-driven solution for global supply chain, focusing on computer vision and generative AI with over 14 years of experience in AI, machine learning, natural language processing, and computer vision, supported by PhD in quantum physics with bachelor and master degree in computer science. His combined deep technical expertise with innovative problem solving. He is proficient in the tools like TensorFlow, PyTorch, OpenCV. Sir is currently developing a computer vision solution to monitor vaccine production environment and exploring AI transformative potential in healthcare. He has introduced generative AI capabilities to optimize GSK supply chain process and successfully manage numerous AI and NLP projects on platforms like Microsoft Azure, establishing scalable workflow. Now, their aim is to make revolution in healthcare delivery and outcomes through our cutting-edge AI technology. With this, I would like to request our expert, Dr. Subhrajyoti Mandal, sir, to kindly enlighten us with his words of wisdom. Sir, please, hand over to you.
Thanks, Subha, brother. I have I'm audible, right?
Your slide is visible.
Okay. Also, my voice is clear, right?
Yes, sir.
Yeah, thank you. So, thank you all. Just I'm switching up the video for the better internet speed. I'll again switch on when the Q&A will start. Okay. So thank you for giving me this opportunity to present the machine learning in EV and automobile industry. So about me, as mentioned, I am Subhajyoti Mandal. Currently, I am situated in the Bangalore. I have been almost 15 years of experience in the research, machine learning, NLP, and computer vision. So currently, I'm working with the GSK, the GlaxoSmithKline is the UK-based pharmaceutical company. Almost in 5 years, I have been involving with them, and here my role is to create a computer vision solution for computer vision and NLP or GenAI solution. This is currently I'm situated in Bangalore and working with the GSK. My education background, I have done the BTech and Intech in computer science, and then I have done the PhD in quantum mechanics from NIT Durgapur. Currently, my research interests in computer vision for improvement of the healthcare and the smart manufacturing process. Today, I'm going to present how the machine learning or artificial intelligence or deep learning can improve the EV vehicles, especially on the self-driving car or automobile industry. Mostly, I'll cover the four content. First is the introduction of the machine learning, introduction to machine learning for the self-driving car. So I'll not go talk about the power station or charging. So this is the issue currently we have. I'll talk about more of the how the machine learning can improve those things. The second, we'll talk about the core machine learning technology where we can improve our self-driving car or EV vehicles. And third, I will give some real case studies where already the company has implemented those things and it is successfully running in the US or UK country, not in India. And what are the future aspects and where we can do more research, so that will give some light. So this is the historical slide. Mostly I'll talk about the unstructured data. So if you see the road mapping, when we started the handling the unstructured data almost in 1980s, where when there is a documents, if you want to know if the documents is a good or bad or what is the sentiment. So that time in 1980, we had only one technology called bag of words. So the bag of words means in a document, if you have multiple goods, so these document will consider as a good sentiment or as a good document. If it is talking about the multiple bad and negative words, so then it will talk about the negative sentiment. But there is a no option to capture when we are talking about the good but in the negative way, or when you're talking about the bad but in the good way. So that was not there. Then in 90s we come up with a new algorithm called TF-IDEF. I know who are working in the machine learning and researching on the machine learning, they know. So that is term frequency and inverse document frequency, when we can understand little bit of the sense or sentiment for each sentence over the documents. Then later 2000, we developed a generally features-based model like the support vector machine or logistic regression, and the two-layer neural network, where generally we extract information from the data and then we create a machine learning model so that when the new data will come, that model based on the learning, they'll give the insight or inferencing. After that, in 2010s, Google has published a good algorithm called word embedding and deep learning. That is the major change, where we can totally read the document in fully, like where the human can read. And word embedding is a good concept where you can extract the information or the sentiment of the information from the document. Then in 2027, there is a big research happened in the transformer model. So they are now, the GNA actually started from the 2017. There's a good paper published. I know if someone wants to research, so this is the good paper. Attention is all you need. So if you read this paper, you will get to understand how the machine learning model can understand language, how like the human can understand. And then in 2019 and 20 onwards, we got the large language model. Now everybody is talking about. So in 2023 and 24, we have a GPT-4 or Llama or various LLM models, where if you want to ask anything, they'll give. If you want to create a PPT, they'll create a PPT. If you want to create a report, it will create a report. If you want to create a project, if you want to create into project, it will give the project. Currently, we are using also the GitHub Copilot, where automatically, if you give some context or prompt, it will write a code for you, and that code, if you do little bit of the fine tuning, you can deploy it into the current production model in current production. So this is our overall roadmap in the GenAI. But I'm not talking about the statistical model that is there last 30 years when we started the statistics. So that is still there, but the implementation of the statistic now is limited because everybody is going toward the GNA or the deep learning model. So this is just the basic overview. What is machine learning? As I said, machine learning is the algorithm where the algorithm can learn from the data, try to understand pattern of the data, try to understand what are the key features from the data, and it create a model. And when the new data will come based on the understanding and the pattern, it will give the suggestion, it will give the prediction, or it will give the inferencing. So earlier it was three types of machine learning generally used to follow in the industry: supervised, unsupervised, and reinforcement. Current trend in the industry, because we fully don't rely on the machine learning. So in every project, when I'm implementing the project in the healthcare, where the patient is the first, and whatever whatever the algorithm we are running, I need a almost 100% accuracy, because it's a life matter. Because whatever the algorithm is taking the decision, that will somewhere some the life is dependent on that. So in every machine learning project or algorithm what we have deployed into the production, all algorithms, end of the day, we have a human in the loop. So that architecture we have created in the industry, how the human in the loop will fit into the machine learning lifecycle project. So that I'm not going to today, but we have this thing. Then the historical context, already I explained how we started from the basic bag of words to the GenAI model, so that I already covered. Next, this slide I talk about the key role of the EV. So if you talk about the electric vehicle, so what are the area we can optimize through the machine learning? The first is the efficiency optimization. So currently, whatever the EV vehicle running, you can implement, already is implemented some ML algorithm to optimize the EV vehicle prediction of the route, driving behaviors, and the battery. The second one is the battery management. So battery management is a key factor because still we are not there with a good battery management. So when I'm talking about the Bangalore, it is a 10 kilometer. It will take sometime 40 hours. 10 kilometer can take 3 hours also. So it depends on the jam. So suppose I have put full charge in the battery in the morning and started going to my office. I don't know. Suppose it is showing the 300 kilometer, the battery will go. But still the car is on. I'm stuck in the jam. Battery is slowly going down. So it's unpredictable how long the battery will take. So the battery management is key aspect when where the machine learning can evolve. We can implement a lot of machine learning algorithm to optimize the battery life cycle. So that is the key area where the research can happen, and this is the most thing we have to do a lot of research for the battery management. Second is the predictive maintenance. This part we are good. So now the model or machine learning model is so advanced where earlier we can predict the when the maintenance comes. So all the data where when it is running, all that sensor data we can capture in the data, and we can put some neural network based model or some uh, deep learning based model where it will predict, okay, so when the next maintenance will come, so what are the current situation. Based on the current situation, you can put any kind of time series model, and that time series model can tell, okay, so now the car condition is there, within another 1,000 kilometer you need a service, or another 5,000 kilometer you need a service. Because the EV's car is not a mechanical car. In earlier mechanical, okay, so I have to drive 10,000 kilometer. After 10,000 kilometer we need a service, but here we don't know. Because if you see the mobile battery itself, when the mobile is new, the battery is giving more backup, but slowly after 1 year battery backup is decreasing. So these real-time prediction is important for machine learning model. Can those kind of prediction machine learning model can do. And the second, the most advanced technology now we are using in the US or UK is fully in the self-drive car, like the automation driving. But here India, is most of the car is coming as a ADAS 1 or ADAS 2, where they can predict the lane, they can predict the speed. Is there anything in the object is there, so they can detect the object and they can put the brake. So that's things the autonomous driving system where we can use the machine learning, and currently we are using the machine learning. So the next I'll talk about the self-driving car. So initially the car in earlier, maybe 10 years back, the car was in fully the mechanical car. Slowly we converted this mechanical car to electrical cars. So we put a lot of the sensor. Earlier there is a car, there's no sensor. Now we put a lot of the sensor. So like the automatic headlight on. So when the light is coming, the car sensor is detecting, okay, now is the day, now is the day, will switch up the headlight. When the light is low, slowly the sensor is detecting, okay, so now the environment light is low, now I have to switch on the headlight. So like this, then automatic rain wiper, this thing is coming. Then slowly we are transitioning to the autopilot. So autopilot means fully automatic system where there is a multiple camera situated in the car, there is a multiple sensor situated in the car, where the car is following the GPS to the real time. It is capturing the image in a 30 frame per second, or sometimes is a 60 frame per second, and every image they are analyzing, okay, the road is free, I can go, road is free, I can. If there is a vehicle or there is any object, instantly they are detecting there is an object, okay, the next action is just put a brake. So continuously this field is evolving, and the more major role for here is the computer vision algorithm. So if your car is having the good computer vision algorithm, then it will predict or it will act is like almost human. But sometimes is the algorithm is not detecting the object properly, or there is some error, because we know the machine learning is a probability study solution. It's not a deterministic solution where I know a equal to 2, b equal to 2. If I plus a plus b, it will be always 4. It's a probability solution, and in probability one is the impossible, is a theoretical is not possible. So every machine learning solution is a accuracy. When you measure the accuracy will never be 100%. So there will be always error. So our job as a machine learning engineer or the researcher, how we can reduce the error. So what are the things, if I put more, then we can reduce the error? What are the features I can give more into the model so that we can reduce the error? Sometimes we have to do error based on the situation. Like, okay, so I need a true negative high. Okay, I need a false positive high. So how we can fine tune my model, how we can take the soft value, that is the predicted value, how you can optimize these values so that my false positive will be high but the false negative will be very low. So like this we have to detect. Okay, so suppose, so for this self-driving car, I'm giving an example. Suppose I put little false positive high. Okay, so that's mean there is no object, but suddenly there is a shadow, and that shadow is the model detecting is a human, and that's put a break. That is fine, right? There is no object, but the car put the brake. But there is an object and car missed it, and there is no brake. That is the high danger situation. The accident can happen. So like this, when we create the any machine learning solution, all accuracy based on the my requirement generally optimize this accuracy, and then we try to achieve the more accurate results. For this case, negative, this false negative is very important. Means there is a human and model is not detecting, or the computer vision algorithm which is put into the self-driving car is not detecting as a human. So is a very dangerous situation. But if it is a false positive, there is a shadow or some different object, but still model is detecting, okay, human put a brake, that is fine. So just we put a brake, but there is no accident. So like this, a lot of algorithm we have implemented into especially the computer vision algorithm we have put into the self-drive car, and now the Tesla or Google, they are successfully running the car into US, but it's very difficult to run into the Indian environment. So importance of machine learning for autonomous vehicle. One is, I say, in enhancing the safety, like this, how you design your algorithm, how your model is detecting the object, how it is detecting the signal. So the signal detection also. So in India is a very crowded city. Here the signal detecting is very difficult. Also in the road is not, we are not following any rules in the road, but in the US or UK generally follow the follow the rules in the road. So those country, the EV and automatic car is very sufficient because there is a less people. We have a lot of power station where you can go and charge the car. But the safety also is, there is safety is high because of the less people. But here, if I same car, if I run here in the India, any situation, any city like Bangalore, Mumbai, Delhi, it will be the high risks, because in every second there's something in object into the road. Second is the improving the efficiency and navigation. So India, a lot of the work is happening in the road. So suddenly, suppose in the morning the one road is open and in the afternoon there is a close. So how real time or how the navigation. So this map also we have to evolve more in traffic in India traffic also. So there is a lot of work is required for improving the efficiency and the navigation. The third is the user experience. So when you are driving the self-driving car or any kind of car, now there is a camera also inside into the front of the inside of the car. So that camera is basically learning or taking picture from the driver and taking how the driver is exhausted or not, is it tired or not, how the driver expression, taking from the input from there, and then say, okay, now the driver is tired. Okay, there is an, I think there is a better, you can stop 30 minutes or 100 minutes. So these user experience we are taking. Also we are taking from the how one person is driving, what is this driving pattern. So that also we are taking, and creating a model, and that based on the model we are detecting. So the most machine learning model which you are using in the event industry, first is the any neural network based model, that is a CNN or LSTM kind of model, where we can control the voice, we can control the image. The the second more important algorithm, we are using the image and the video recognition. So especially in the image or the computer vision, generally two kind of algorithm generally we use. One is the object detection, so in object detection, and second is the classification based algorithm. So in object detection, especially in the Facebook has published the detector tool, that I have also implemented a couple of detector to algorithm in my vaccine, where we have to identify how many bacteria and colonies are there. So the detection tool is very good for identify the small object. Then there is a very good algorithm is available called ULO. So in ULO, there is a lot of variant is there, ULO 1, 2, 3, 5, 8. So that is good for the big object or the face detection. And then when it is required, the classification, okay, so now we identify the object, but what is the object? Is a man, human, it is a man, car, or any kind of different object or animals. So that then it will come the classification algorithm like the CNN or LSTM, or now is the VLM based model, or the deep learning based model. Then the third one is the generally using the lot of in the machine learning is the sensor data processing. So in card there's a lot of sensor. So all that data we are consuming or storing into the central hub or in the data lake, and then we are analyzing those data, and then based on those data we are predicting. Okay, so like I'll giving example. Suppose if you're running a car, and it is taking the data from your tire pressure monitoring. So suppose there is a down into one tire pressure, it will give the indicator, okay, so your right side or left side tire pressure is down, there might be chance a leak, you can check the tire. So all those things now is fully automated, and those machine learning algorithm now in evolving and good ride experience in, and it's a good experience into the EV industry. So it's basically we are evolving. So core machine learning, as I mentioned, the object detection, that is the first, any kind of self-driving car fast require the any all good object detection algorithm. And then the segmentation is basically how we are segmenting those objects, because it is a human or it's a animal or different kind of object there, and is a the stone is there or not. So those kind of thing, the segmentation. And then is the lane detection, that is very important. Where changing the lane, my algorithm can detect this now, or some kind of, suppose when you're changing the lane in the backside there is a car is coming or not. So all these ADAS kind of thing generally we use for computer vision to to check this kind of problem. Next is the sensor fusion data. Generally, the various type of data you'll use. Basically, the detail describe the title of center. So which kind of camera you are using, what kind of data you are processing, and how. So another important things in the machine learning model, when you are generating the machine learning model, that model is trained into the huge data. And when you are creating this model into the maybe NPKL format, that is a very old format, currently we are using in the ONX format or .h format. This model itself a very huge model. Okay, so if you take the any kind of GNI-based model, okay, so like the GPT-4, so that model is itself a 2 GB model. Okay, so but how these 2 GB model I will implement into the, I will put into the camera, right? So that we need is the very good optimization algorithm technique, where the 2 GB model we can optimize in a suppose a 2 MB model, because the camera memory is limited. Okay, so that's things is there is also option where we can do some kind of research to optimize this model space. Then is a data integration, that is when we are generating the lot of data from the sensor, where we store the data, where we'll integrate the data will be the cloud or not. So when we are using the cloud, it depend on the network connectivity. Suppose there is a no network, can the vehicle access this data where there is a no network? If it is not accessible, what are the minimum data I can put into the vehicle as a memory? Like when you generally checking into the map, right? So then in some case there is an option you can download the map and there is a no activity, still you can follow this map. So these are kind of thing also required for the networking purpose. There also you can do there also you can do some kind of optimization, and there is an option we can do some research also. So deep learning algorithm already I covered. So the basic how the algorithm works. So generally we select the algorithm based on the data. Then we divided the entire data set into the training test and the validation set. Training test generally any machine learning algorithm. First we'll do the training in the training set. Then we'll do the testing in the testing, and then we create a gold standard data. In industry generally we follow gold standard data where we validate all this model. And when we create any kind of machine learning model or computer vision model, they should pass into through the validation data. And the validation data generally will try to put all kind of possible scenario, so that when I'm deploying this model into the production, I'm deploying this model into the self-drive car. So my knowledge, whatever the combination is, the combination of error can that can handle this model. And then the real world application, generally I'll talk into the next slide. So competitive landscape for the automobile vehicle. Okay, so the major player, as I said, currently we are using, so currently the Tesla or MEO is basically the Google product, or Uber. Generally they are using the fully AI algorithm for their EV vehicles or their vehicles. Then market trend, as the last speaker mentioned, Ajit said. So we have to work into the two factor. One is we need a high machine learning model that can optimize or predict this scenario. Also, we have to work into the battery point of view and the charging station point of view. So this is key factor. So when I'm suppose my car, there is a no petrol, right? I can stop any petrol station within 2 minutes. I can do the full car, the car petrol will be full. Again, I can drive. But when we are doing the EV station for charging, if it is a fast charger, it will take 45 minutes. If it is a not fast charger, it will take maybe 1.5 hours or 2 hours, right? So in a day, how many car can charge? So if I'm driving 200 kilometers from place A to and B, and it is taking 3 to 4 hours, but in EV vehicle, because of the charging, it will take maybe another 2 hours extra for the charging. So those things we have to optimize. And there is a lot of regulatories, because now everybody is using the AI, but every company is putting the AI governance rule. So what algorithm I am using, so this algorithm, how safe this algorithm is, this algorithm is governed by the AI governance team or not. In our industry, especially in the healthcare, generally when you create this machine learning model, all this model go through the regulatory, and this regulatory means in a particular environment, in a particular data, in a particular situation, when I'm generating the model and model is giving some the result. If I replicate same environment in after some time of span, this model should give the same result. If the model is not giving, or the solution is not giving the same result, so that's mean I don't have any control is in the machine. So that's mean this machine is not reliable. It can predict based on the time. So this time predicting this, another time I don't know what kind of data it will predict. So that's why all the regulatory is very important for any kind of machine learning solution, whatever it is, EV or thing. So in all situation, my algorithm and model should give the same result. Okay. So currently the self-driving car generally you're seeing in the mostly in the Tesla. So the Tesla is a huge. There is a Model X, and another is SUV type of car. So those cars generally the European country or UK or US based country they are using. I have a couple of colleagues in the UK. They are using Stapler. Good. So I have seen when they're taking the call in the car, where car is generally go, and they have a control in the brake, but the steering is automatically moving. So that's fantastic, but their road is very empty. this is also the Google have the Waymo is a basically Google product. So they started long time ago, but still their vehicle is not into the market or not into the industry level. And there is a cruise automation. There's a lot of work also done in the cruise automation, but mostly in the current situation, the self-driving car, mostly the Tesla, and others car they are using the ADAS, where they can predict the ADAS 1, ADAS 2 technology that they are using the mostly car. You can Hyundai or Skoda, this kind of car also they have ADAS, or the Mahindra also. But their ADAS, when I've seen couple of ADAS car, something suppose what is the problem I'm facing, the real-time problem in the ADAS car? The India, some roads are the single lane, right? So when I'm overtaking one vehicle and there is another vehicle is coming, if it is a my control, I know I'll pull the accelerator, I can go. But the problem here in the ADAS, so that ADAS is taking, there is seeing the object, but how many distance, so that calculation is not accurate. So sometime when I'm trying to overtake, the ADAS is putting the brake, and that is the very risky situation. So the like couple of my friends, they just switch up the ADAS option, because this is very risky in India. Because why it is risky? Because this current ADAS technology is not calculating what are the distance between the when your car is there and the next object. So the distance calculation, generally all the distance calculation algorithm whatever you're using, but that is very good on the numerical when it is coming the object to object. So this distance calculation is not working fine. So that's why the ADAS is not working. But in anyways, generally the very less traffic, where the ADAS and the self-drive car is working there. Then what are the case studies and the pilot project is happening in the urban area? As I said, in the US, UK, there is a lot of projects. There, the current project is going, especially in the Tesla. They are still evolving and researching the the machine learning model or the deep learning model or the AGI model, that is called artificial general intelligence model, can improve the driving experience, can improve the self-drive car. There's a lot of project are happening into the highway also in the Bangalore, right? They are put all the AI based cameras. So when in from one signal to another signal, suppose there is a signal between A to B, there is a 10 kilometer, and 10 kilometer situation, based on the current traffic, they know this much time should take. But if any car is going fast beyond that, and they reaches and they it is reaching the second point very fast, so AI is calculating, okay, so that's mean this car has driven almost 120 kilometers per hour, so then it is detecting and putting the fine. So all those things AI based camera is putting into the highway for the better improvement of the society and better handling the traffic. This is also happening. Then what are the challenges currently we are facing? The first is the technology limitation, especially on the charging point of view. We need we need to do a lot of work. Then is the battery optimization. We need to do a lot of work. So those are and also there is a lot of improvement is required to the new improvement is required for the machine learning model is itself. So we are basically evolving the new algorithm, so that will increase. Second is the regulatory and the ethical point of view. So when my car is running, when the self-driving car is running, it is taking your full data, it is handling your mobile, it is taking your full data. What are the ethical things? Is the data is leaking or not? So the data privacy is a very important. In India, generally you don't follow the data privacy, you are not bother of the data privacy, but US and UK, they are very strict about the data privacy. Then is the then second is the regulatory. Regulatory means when you're riding in the car, any kind of self-drive car. So that's mean there is the AI-driven car. Is it following these country rules and regulation or not? Okay, so these things is, and then the acceptability. So currently, according to my experience, we are good for the hybrid car, but still we are not ready for the self-drive car in India, because India roads are not ready to take drive car automatically, because there is a lot of problem, and that's why Tesla still didn't test it in India. So future scope where we can do more improvement. One is integrating with the smart grid, which last speaker, I think Ajit mentioned. So the smart grid integration is very important. We have to improve the grid. Second is the ethical point of view. All these models are ethically or taking, so all these data privacy, data governance is following and not. Second is the advanced battery technology. Still we are not in the, still we are using the lithium battery, right? So the battery technology is not good currently. All the EV vehicle which is running into the market, right? So they just launched. After 3 to 4 years or 5 years, when they have to change the battery, that time the cost will come 6 to 7 lakh. So if you see the maintenance cost, currently you're seeing it, okay, is very less. The petrol cost or the diesel cost is high for running that. But when the situation will come, when you have to change the battery, that time in one shot it will take 6 to 7 lakhs or maybe 10 lakhs to replace this battery. So the battery technology you have to improve. Still we are using the grid lithium battery, so there we have to improve. Still there is a lot of optimized algorithm we have put into the battery technology. So the battery currently, if you're seeing the Apple, so they have implemented, okay, there is a the pattern based charging. Okay, so when you are putting the charge into night and when I'm taking out the phone, so the algorithm is learning your pattern. Okay, so you are putting charge into the 10 o'clock and you are taking out your phone is morning 7 a.m. So 80, after 80% they'll stop the charging, and again in the 6 o'clock they'll start the charging and finish this 20%. So these kind of this kind of algorithm or this kind of AI based technologies we have implemented in the battery to improve the battery life cycle. Second is the long-term social impact. So that is very important in the reduce your traffic. So when so there is a two situation in India especially. So when you are driving in the daytime, when you is driving in the nighttime, so all these algorithm currently the computer vision algorithm is good for the when the image is good, light is good, but when it's a nighttime and when it's running into the suppose in the fog time or raining time, so those algorithm is not ready to take those kind of scenario. So in the night time there's a foggy time, so the all this object vision algorithm is not able to clean those image properly. So there's a lot of work is required to or a lot of research is required to improve this algorithm. So that is also long term thing. Again, technology advance. Currently, what I am seeing in the current within 3 to 5 years, it will come. First one is so now we are talking about the GenAI, right? The generative model or the large language model. The next will come is the AGI. So if you see the OpenAI, they have started already research into the AGI, the artificial general intelligence model, where the model can predict based on sentiment. Currently, there is all the model is predicting based on the data. There is no sentiment involved in this data. So these AGI kind of things come, and the next is the quantum computing that will come. So currently, all this model which we are using or the algorithm which we are using, that the size is huge, but and it's require a huge GPU and CPU to run this thing. But when will same algorithm when will run into the quantum level, so that time in a single chip will be the capable to handle suppose a million of image in a particular time frame, right? So currently the processing of image also is 4 to 5 seconds. So a lot of computation algorithm I have implemented in my company, but their time is analysis image to 4 to 5 seconds. But in right, if you see in the electric vehicle or self-drive car, right? So when you have to take the decision within 1 second. So if your image is coming, the 30 frame image is coming, and you are taking 4 to 5 seconds to analyze, okay, so these how many distance this object I can go or not. So that situation in the real time will not get. So the car will come and there is a chance with the might accident can happen, right? So all those things, if you put into the quantum level where the processing time will be the very million of second, so that is will be the next improvement into the self-drive and automation in industry in machine learning point of view. Social impact, basically in GenAI and all these AI, there's a lot of things is happening, like it is taking the job in the market, it is taking the things, any kind of regular weighted job, right? So suppose any kind of daily weight job, suppose I'm talking about when one image come and one person is checking those images and taking some decision, those kind of job is a chance, yes, we can replace. So that's why we are doing the automation. But that person we can use from the different way. We can put this person in the human in the loop. So currently, suppose one person is verifying 1,000 images manually. So instead of 1,000, okay, maybe the all the true positive and false positive, right? So if I put all the false positive accuracies 120%, so only the two positives, so the 10% and 20% image, the human can validate. So we can optimize there. So that, but still we need a human. So that's the thing is there. Ethical and legal issue already I covered. What are the ethical aspects required, especially the data privacy. Second is the policy and a regulatory in the current country is following, and the third one is this safety. Okay, so ultimate AI is a probabilistic algorithm, right? And I am running this self-drive car in a country based on some probability value. Okay, the accuracy is 99%. That's mean the 99% the car will take the decision. 1% there is a chance the car will not able to take the proper decision, and that accident might can happen. Can government take these risks? No, right? So these safety things also require in the self-drive car or any AI based car when it is running into the current society. So that thing is required. So the lot of work still we need for self-drive car when it will come into the market in proper fully manner. So let's see how it will go. So thank you. I have tried to cover mostly in the machine learning part and the application of the machine learning algorithm where you can put into the self-drive or electric vehicle car. What's the current situation in the self-drive car and where you can do the optimization. So that's I try to cover. If anyone would do some kind of research, I was going through a couple of research paper. So those thing I think we can walk mostly, especially in the if it is the AV vehicle, talking about the AV vehicles, first research is required for the battery management. So that is the first thing we have to do. Second, we have to walk into the computer vision algorithm where the algorithm can take the decision into the various situations. So currently, if the environment is clean, shiny, algorithm is taking the decision, but the algorithm is there fully raining, right? So that time the visibility will go down. So these kind of noise will come. Can the algorithm take the decision? So these research is still required, and we can publish a lot of research paper there. Also the charging point, so how we can optimize the charging point. So based on the current road condition, and suppose I'm traveling to current point A to point B, and what is the travel time required, where the person can stop the car for tea or for the breakfast or for lunch. So we have to target those situations. We have to take those place, and there you have to put a lot of the charging station. So that when the person is having their breakfast, they can charge the car. But instead of when the car needs a charging. So in the petrol or diesel car, we know, so there is no the fuel is going down. Now I have to recharge the fuel. But here we have to put some condition. Okay, when a person is driving from A to B in the morning, what is the optimize he can stop, and we can suggest, okay, so now we can do the charging. So this is the charging point, you can do that. So these kind of predictive things, if you suggest into the user, so that will help. So this kind of research is required, or all this predictive model is required, and that's for that we need a lot of data, and we need a lot of yes, data, and a lot of charging point also required. So this thing you can do some kind of research and do this. So that all about I have today. Any question I can take up?
Dear participants, if you have any queries or question, you can ask. Sir is waiting for your question. Sir, I have a question.
Yeah,
Sir,
thank
to implement the self-driven car in India, the
you.
speed breaker is also considered. We have to consider the speed breaker also. You are saying that.
Yes. So if you see in all outside country, means when I visited US or UK, so their speed breaker is they have created based on some guidance. Okay, and this speed breaker is always follow the same guidance. But if you see India, so some speed breaker, if you see, it's a huge, some is less, some is already broken. So all this data is different way here. So that is also definitely you have to consider there. So my experience, self-drive car in India, it will take a lot of time. Still, we are not ready for the self-drive car. EV also currently there is a batch of user they have taken the EV car, but we'll get to know this car will sustain or not after 5 years when the battery replacement will come. So that time cost will be the huge. Second is this EV car is good when you are driving into the city condition. Suppose I'm driving from my home to office. I know from home I have a charger. I'll go to office. I'll put the charger. But if I want to drive, do some, suppose I'm going from Bangalore to Mysore or some Bangalore to Kerala, right? I don't know I'll get the charging station or not. And India is a very, suppose there is a power cut, right? In charging station there is a power cut, I'll get the charge. So all those things you have to consider. So for still we are hybrid is good, but we are not ready for the EV.
Thank you, sir. And participants, if you have any queries regarding this topic, you can ask.
I think all they need a tea break almost 4:45. I think this session is happening from the morning, right?
No, sir, it is actually started after 2 p.m.
Okay, after 2. No problem. Thank you.
Yeah, I think there is no question for this session. So thank you, sir. And we will definitely meet in offline. If there is offline also, we can actually consider you here as a speaker, sir. We
Okay,
hope
thank you.
so. Thank you, sir.
Yeah, thank you. Bye.